I'm Sean Davitt, and this is my dad, Terrence Davitt, and he is a firefighter on Ketchum Fire Department. And so, do you use any math in your job?
Actually, we use a lot of math in our job, and one of the most important things is to make sure when we're flowing water through a fire hose and out the nozzle that we have the right amount of water coming out of the nozzle. And to do that, we have to know what engine pressure, what type of friction loss we have through the hose. So I have a formula over here that I have to do in my head every time we flow water, and it's called our friction loss calculation. And here it says friction loss per 100 feet of hose is 2Q squared plus Q, where Q is GPM, or the gallons per minute, that we're flowing divided by 100. So our example here is 500 feet of hose, 2.5-inch hose, flowing 200 gallons per minute. So Q is the gallons per minute, which is 200 divided by 100. So we have 200 divided by 100, so Q equals 2. Now we import that into our friction loss equation of 2Q squared plus Q, which comes out to 2 times 2 squared plus 2, which is 2 times 4 plus 2, which then is 8 plus 2. So our friction loss is 10 per 100 feet of hose. So if we take that 10 per 100 feet of hose, 5, our friction loss would be 50. And so I would have to incorporate that in when I do my engine pressure.
Okay. Do you use any more math in your job, or is that it?
Oh no, there's plenty of math. In fact, when we put up ladders on the wall of a building, we have to use a formula to put them at the right angle. And over here I have it written down, so for the proper ladder placement, the ideal angle is 75 degrees out from the wall, or sometimes it's hard to figure out, the butt, which is the bottom of the ladder that touches the ground, the butt of the ladder is out 1/4 of the distance of the ladder's working height. So if the top of the ladder is up against the building is 20 feet high, you divide it by 4, or 1/4, and it equals 5 feet. So the bottom would be 5 feet out. So you can see I have a diagram here with our ladder up against the wall. And it's 20 feet high, that's our working height. And it's either a 75-degree angle, or 1/4 of 20 feet is 5 feet. So that's how we make sure it's at the proper angle.
That's interesting. Do you use math when you're in an ambulance call?
We use math all the time in the ambulance, and primarily because when we give someone a medication like epinephrine or atropine, we need to give it to based on a person's weight in kilograms. And most people know their own weight or their family's weight in pounds. So we have to be able to convert pounds to kilograms. So right here, this is how we normally convert. You would multiply the pounds by 0.45. So a 200-pound person times 0.45 equals 90 kilograms. But sometimes that's really hard to remember in the middle of the night. So an easier way for me, and a way a lot of the paramedics use it, is you can use the pounds divided by 2, and then you subtract 10% of that number. So for the same example, a 200-pound person divided by 2 equals 100. Then you subtract 10% of 100, which is 10, you equal 90 kilograms. So it's the same answer, it's just 2 different ways. And I prefer to do it the second way.
That's interesting. Thank you, Terrence, for your time, and that was very interesting.
I'm glad you enjoyed it.